Destructive testing. Yay! All right. So we're going to talk about destructive testing types and how we prepare the specimens. Yippee skippy. All right, here we go. The first one is a tensile test. What does it do? Well, what they do is they put a piece of material right in here and they grip it on both sides. They grip it and pull it until it breaks. What are we able to find out? We're able to find out a lot of information from this. The first one is tensile strength. So we're able to use not only our filler metals, but our base materials and find out how strong they are. Okay. In this, we can do what's called a dog bone. Okay, looks like a little dog bone. I'm going to normally use these and I'm going to cut these out for a lot more for pipe. Okay. And we're going to do tensile tests on these. We're going to pull these apart. Okay. Now, we can also do tensile tests with different ones. They can be round areas, okay, and they can just have a plain end. They can have a shouldered end. They can be threaded. They can have a pin. Pretty much, it depends on the tensile machine that's being used. How the ends are determines how the end is going to be. Sometimes these are machined, sometimes they're not. Okay, we have an extensometer. Okay, now this is pretty much a digital way, a computerized way to tell how far the piece stretches. Okay, we're able to do the original length of the piece, and then after it's stretched, we're able to measure it again. Okay, and we're going to be able to find out the percentage of elongation and percentage of reduction. Okay, so we really have to look at these lines. Okay, so this is when it's first loaded. Okay, and then as we keep on going, this is how it starts to deform. This is our deformity. Okay, percentage of elongation and elasticity right here, and this is when it fractures. This is the point where it stops. So we can see it strains, it strains, it strains, or it stresses, it stresses, it stresses, and then it starts to even out, and then after it even out, it breaks. Okay, so the percentage of elongation can be found when we put it back together, and we're taking the difference between the two pieces. A peel test or a shear test is when a specimen is peeled apart. A lot of times we're going to use this for spot welds, but we can pretty much use this for any type of weld we're doing, but the majority of usage is spot. Guided bend test. Pretty cool stuff. Pretty much there's different types of guided bend tests. Ultimately, we take this is called the plunger, and this is the jig, and we put your piece in here, and we push it down with considerable force, and we bend it, okay? We can also have one that's bottom ejecting, and there's also a type of jig. It's called a wraparound jig. And what's going to happen is we either put this area here, this would be face in tension. If I flipped it around and the root was down here, this would be root in tension. Or if I had the piece at the side, it would be the side in tension, depending on what we're trying to test. Okay, so we're either stretching the root, the face, or the side. Okay, and this is what it's going to look like. We're going to cut out little pieces. According to the D11, we're going to get your piece of material. Let's see if they have a picture. Well, they don't. So we're going to get your plate, okay, and we're going to cut off an inch from both sides. And then after that, we're going to slice it into 3/8 inch pieces. And we're going to grind it flush. After we grind it flush, we're going to give it a little bit of a radius, because we know that if we don't give a radius and it's a sharp edge, we're more likely to have cracks, and it will give us a false indication that the weld is bad. Okay, so this would be a wraparound jig. Okay, same kind of thing. Here's your material, and this is where we can bend it around what's called a mandrel. Fillet weld break test. It's just what it means. So before they break it, normally what they'll do is they'll slice it right here, and they'll slice it right here, and they will polish the edge of it so that they're able to put an etching solution or an acid so that they're able to see the weld nugget and how far you have of fusion and penetration. And then they either take a ram, they hit it with a hammer, and they fold the top plate into the bottom plate where the weld is. And they want to see what the penetration is and if there's any type of discontinuity inside the weld itself. Nick break. This is fun. I love it. So what they do is they take the specimen, okay, and they actually saw into this top. It's about 1/8 of an inch saw. And then they hit it with a hammer until it breaks open. And when we look into the interior, it's going to break open. And we want to see if there's any type of discontinuity. Is there slag inclusion? Is there porosity? Is there any kind of issue in here that we need to understand? Okay. The other ones are hardness tests. Okay. Hardness tests are used in a lot of manufacturing. Hardness tests tell us how hard the base metal is versus my heat affected zone versus my weld material. Okay, if we're too far apart in hardness, it can affect my weld. It can break because it's too brittle. And normally we're going to have issues in the heat affected zone. So this is relatively where they find issues. Okay, so Brinell hardness test. Ultimately, let me explain about hardness tests. Hardness tests are all the same. We're going to push an indenter into something to find out how hard or soft it is. But everybody wanted their name on a test. So there are different types of tests with different types of indenters. The first one is called Brinell. Brinell uses a 10mm ball. And pretty much we put a load on it. We measure it first, the ball, and we're going to put a load on it. And then we put another load on it, and we determine how big the circle is. Okay, that's what it is. So here it is. If I have a soft metal versus a hard metal, a softer metal is going to give more of an indentation, and a harder metal isn't going to have such a ridge. Okay. Next one, Rockwell hardness test. Pretty much we use 2 loads. And we're going to do the same type of thing. We're going to measure how far or how big the indentation is. All right, micro hardness. Micro meaning small. And we're going to go with very, very light loads, less than 200 grams. And this is where we're going to cross our base material. We're going to go across our heat affected zone as well as our weld. And we need to see how far variance there is. All right, here we go. Vickers. Vickers is a micro hardness test, and we're going to use a pyramid-shaped indentation. Okay. This one is the Knoop micro hardness test. We use a diamond-shaped indentation. Okay, so we can look at the mechanical properties when we're using a destructive test. Destructive test allows us to kind of look at the information that we have, and we're able to build these charts to better choose the correct material. It also helps us diagnose, like when we're working with procedures, making sure that we're using the correct materials for what we're doing. A lot of engineers are going to look at the strain rates and the stress rates, and they're going to make sure that the material that they're choosing is correct. Okay? So like if we look at this, strong but brittle. Okay, this is where it's fracturing. Well, this is weaker, but it's a little bit more ductile. So we need to look and see, well, what if we found something kind of halfway in between? All right, Sharpie V-notch. Let me tell you, this is my most favorite test in the world because you get to break stuff. Ultimately, it's called the Sharpie V-notch because what happens is they can either get a piece of base material, they can get a piece of the weld material, anything like that, and they machine it. They machine it into a perfect square, and within that square, they create what's called a notch, a V-notch. okay? And this V-notch is centered on this little breaker thing, okay? And a big pendulum hits it, okay? And we're judging the potential energy and the stress strain rates from the V-notch and when it breaks, okay? So here it is. So we can take specimens from different areas to create a Sharpie V-notch test. So then we can use those same types of things with different orientations, okay? The drop weight test. They say it's more reliable than the Sharpie V-notch. I have no idea why, but pretty much all we're doing is putting a specimen on it, and then we're throwing pretty much a rock at it. And we want to see what the deflection is. So from the deflection, we can determine how brittle or ductile a piece of material is. So here we go. Here is our specimens. This will help a whole bunch, guys. Let's see if I can bring it up here. So when we're doing in accordance to AWS D11, here is our plate. We remove the backing plate once we're done. Okay, we're going to cut off 1 inch from here and from here. Okay, and then what's going to happen is these little slices are 3/8 of an inch. Now, depending on the code, depends what we're going to do with it, okay? We can have a side bend, which means the side is in tension. These ones, we can do fracture toughness. We can do all sorts of different ones, okay? Now, we have another one here. This one's for pipe. Same kind of thing. So we're going to take them and we're going to slice them out so we can do a root bend, a face bend, a nick break, or a tension, okay? And then these ones, we can actually, these would have to be like thicker material, and these are going to be machined, okay? All right. All right, so here they say, a minimum separation of 4 diameters for Brinell hardness and 2.5 diagonals for the Vickers micro hardness test must be maintained to prevent disturbances between the weld metal zones and the base metal. What in the world are they talking about? So really what they're talking about is there shouldn't be a big variance when we're talking about hardness between the heat affected zone, my weld metal, and the base metal. If it's too much of a variance, we're going to have a lot of brittleness, and it may change the mechanical properties of what we're doing. All right, we're going to work on points to remember on a different slide. So, or I should say on a different video. Hope this helps, guys. Take care.